Watch the screen. Random words fill a canvas. Gibberish, noise, nothing useful. Then, over 6 quick steps, the noise sharpens. Letters lock into place. And suddenly, a clean sentence sits where chaos was a second ago. That is DiffusionGemma, a new open model from Google DeepMind released this week. It generates text the way image diffusion models generate pictures, starting from noise and refining the whole output in parallel instead of typing one word at a time. Most language models work like a typewriter. They predict the next token, print it, predict the next one, print it, always moving forward in a single line. Each token waits for the one before it, so the GPU spends too much of the moment waiting on memory instead of doing parallel math. DiffusionGemma takes a block of 256 empty slots, fills them with random noise, and runs a denoiser across the whole block at once. It can look forward and backward inside the canvas. Some tokens lock in after a few passes. Others get re-noised and tried again. After roughly 6 to 20 steps, a clean block of text appears. Then it moves to the next canvas. And you can see what that speed looks like in practice. Here, someone types a prompt for a fantasy sword. DiffusionGemma generates the code so fast that the 3D model appears while you watch. A second prompt asks for new colors on the handle. The model rewrites the relevant code, and the asset updates in seconds. The numbers behind that speed. On a single H100 GPU, DiffusionGemma produces over 1,000 tokens per second. On an RTX 5090, over 700. Google says that is up to 4 times faster than standard autoregressive Gemma for low concurrency local GPU workloads. The reason is physical. Token by token generation keeps loading model weights for one small prediction after another. Parallel block generation shifts more work toward compute, hundreds of tokens processed in one pass, which is the kind of job GPUs are built to chew through. Independent testers made the same idea feel less theoretical. One developer ran DiffusionGemma locally and generated a playable Flappy Bird clone in a single pass, code written fast enough that the game was running moments later. Another ran a live session on an RTX 4090 and captured text crystallizing from noise in real time, a canvas of random tokens snapping into sentences right on screen. So what is the catch? Google is direct about it. DiffusionGemma trades output quality for speed. On difficult reasoning benchmarks and long-form generation, standard Gemma 4 still produces better results. Google's own guidance is simple. If quality matters more than latency, use Gemma 4. The model has about 26 billion total parameters, with 3.8 billion active at any time. It is a mixture of experts' design, so the whole model is large, but each step only routes through part of it. Quantized, it fits in roughly 18 gigabytes of VRAM. That puts it within reach of a high-end desktop GPU. It ships under Apache 2.0. Open weights, available on Hugging Face, Kaggle, and Google Cloud. NVIDIA published deployment guides on day 1, and vLLM added native support immediately with custom sampling logic built for the diffusion pipeline. Google also showed it can be fine-tuned for structured tasks. In a Sudoku demo, the base model fills grids but makes mistakes. After fine-tuning on puzzle data, the model solves boards correctly. The diffusion process can revise cells in parallel instead of committing to each number in order. DiffusionGemma is an experiment, and Google labels it that way. It will not replace general-purpose language models for hard reasoning or production-grade text. But for interactive tools, local assistance, code generation, and any workflow where waiting on the model is the problem, it is a real alternative to test. The weights are open, the tooling is ready, and the speed-quality trade-off is now in the builder's hands.